Welcome to the 23rd episode of Byte-Sized JavaScript. In this episode, we'll be learning how to create and manage a monorepository. But before that, let's take a step back and think about what a monorepository is and why you might need one. If you have a project that contains a handful of modules that are supposed to work together, and if each of those modules is published to npm, you will soon realize that it will be quite a pain in where to manage, update, audit, and version control all of these modules and dependencies. Especially if each of your modules lives in a separate repository, then things will get extra painful. Also, when each module that you depend on lives in its own repository, then creating a development environment becomes a hassle too, so as managing versions, or if you are a team working on a project, then contribution will be also challenging. For instance, if you need to make a change that impacts 5 different modules that you have, then you'll have to create 5 different pull requests on 5 different repositories, and then merge them separately and run integration tests separately. And this process is not atomic. I mean, when you make a mistake, then you'll have to roll back all 5 different repositories at once, and things will quickly become out of whack. So in this episode, we'll be converting a multi-repository project into a monorepository project. And luckily, I have a bunch of modules that I manage as a set of separate repositories that I was indeed thinking to merge into a monorepository. So let's dive into it and get our hands dirty right away. At this time of recording, when I visit Byte-Sized JavaScript's GitHub organization, I can see approximately 20-25 repositories that Jedi Focus main repository requires as a dependency so that it can generate one big overarching web application. So my goal in this episode will be to consolidate all these modules into a single repository, and we will be using a tool called lerna to do that. So lerna is a tool that gives great flexibility when managing your monorepository structure, but it's not the only tool. There are other monorepository tools that you can have a quick glance here. That said, lerna is a decent enough choice that you can start with, and as I said in this episode, we'll be using it. So to start, you can either install lerna locally to your monorepository, or you can install it globally. And here I'll follow the instructions on lerna's public website, and I'll install lerna as a global dependency to my system by doing a npm install lerna-g on the terminal. Then I'll create an empty repository by doing git init jedi focus-lerna and then cd into that folder. And in the project folder, I'll do a lerna init, which will create a package.json and a lerna.json that I can base my monorepository off of. And lerna will also create this packages folder that we are going to put our modules in. And each of the module or each of the package will be a folder that has a package.json, and it will look more or less like a Git project with all the dependencies. And the only difference will be that all of the projects with their package.jsons will be a part of this single large repository. And next up, since I already have the recent versions of all my project modules locally, I'll just copy all the projects into the packages folder of my lerna repository. And one thing that I need to pay attention is to delete this .git hidden folder, because our monorepository is the only Git project that we have, and therefore we need to remove these version control information from those folders. And when I do a lerna ls, I can see a list of my projects and what versions are they at this moment. One cool thing about lerna is it's kind of a hydra. I mean, you can run the same command across all of your modules in a parallel fashion by just executing a lerna run command. So for example, if I execute lerna run test, it will run npm test for all the modules that I have inside this packages folder one by one. And similarly, if I do a lerna run flow, it will execute npm run flow for all the modules inside this packages folder. And same for lerna run lint. So it's really useful if you want to execute the same code in multiple packages. Now I'm going to edit this lerna.json and increment its version number. Then I'll do a lerna bootstrap, which will traverse the dependency trees of all my modules inside the packages folder, and then create symbolic links or symlinks under the node modules folders of each of the packages. So for example, if I go into the node modules folder of this Jedi Focus.models package, I'll see that the modules that I declared as a dependency in this package.json have already been symlinked for me to its corresponding locations, pointing to the package folders that they belong. This becomes really convenient when you are actively developing a multi-package monorepository structure. So let's say I want to increment the version numbers of all the modules that I have been working on to a certain specific version and then publish them to npm all at once. The lerna way of doing this is to run lerna publish, and when I run lerna publish, it will ask me how I'd like to increment my version number. I'll just do a patch release. Then I'll get a quick summary of what will change and which versions will be upgraded to which version numbers. And when I type Y to accept all the changes, all my packages will be upgraded and published to npm in parallel. And if I check the package.json of a random package, I can see that it indeed has updated the package.json's version number to the latest version. So you can also use lerna to execute commands in a subset of the packages using the -- scope flag. The -- scope flag will limit the scope of our command to the number of modules that we provide. But it looks like before running the server, I need to install my dependencies. So first I'll run a lerna clean to delete all my node modules folders, and then I'll call a scoped yarn install command under the packages /Jedi Focus module. And after that, if I do a yarn start inside the packages Jedi Focus module, my server will boot up without any problem and I can easily see my application. Now I want to give a more meaningful name to this repository, and I'll rename it to Jedi Focus -monorepo to indicate its usage and its intention. So now I think you can see the advantage of using lerna. Now let's integrate this with Travis, and since we have a Travis YAML at the repository root, enabling Travis more or less boils down to going to Travis UI, finding the repository that we are interested in, which in this case is Jedi Focus monorepo, and then flipping this switch. So when I do a yarn run publish, it first runs pre-commit checks, then builds the project, and if both the pre-commit checks and the build process succeeds, then it will call lerna publish, which will trigger an npm publish in all of the modules under the packages folder, and eventually publish them to npm. So when I push my changes to master, it will immediately trigger Travis. However, the Travis build will fail because the Travis runtime is trying to find the test dependencies and it's having a hard time locating them. To fix this, we'll create what's called a Travis build matrix and run tests in Travis in parallel. So this is the build matrix. It will install the dependencies and run tests for the given Node.js versions that you see here. And then it will execute the tests in parallel in Travis. So let us see it in action. As you see, when we trigger a new build, Travis is running all of these tests in parallel, and when all the tests pass, it will mark this build as green, and it will report a successful build back to the project owners and back to GitHub as well. Well, lerna helped us automate a fairly complicated build pipeline, and that's really cool. In summary, in this episode, we have learned what a monorepository is and why you might need one. We briefly overviewed the options of tooling when we want to manage a monorepository. We learned how to manage a monorepository with lerna. And then last but not the least, we integrated our codebase to Travis and we used a build matrix in Travis so we can execute tests in parallel for each and every single one of our packages. And that's the end of your Byte-Sized JavaScript. Until we meet next time, may the source be with you.